Hello, this is Mrs. Munyon. I'm a little stuffy today, so I apologize for the weird voice. So what are we learning about today? You can see the grid right here, and it's perhaps that you are most familiar with this portion of the grid right here, which is just when you use coordinate numbers, okay? But we are more and more going to think about the other portions of the grid. So what is the goal of today? To be able to find locations on a grid as well as to describe an object's location. So find and describe locations on a grid. Okay, that's simple. So it's a little bit like one of those Christmas papers that I give you just for fun. But before we get started, the vocabulary is really on the second page that you need to know. So let's turn there now. Okay, and I would like for you to just have a reminder of Roman numerals. So the I is a 1. All right, and a V is 5. Okay, so when you put ones together, 1, 1, that's 1 plus 1, that equals 2. 1, 1, 1, that equals 3. And then we have this interesting scenario, 1, V. So if it were V1, that would be 5 plus 1 equals 6. But when it's 1V, that's actually 5 minus 1, which equals 4. Okay? Important when you see these grids, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, 1V, see it right there? Okay? So important to know those Roman numerals. And if you notice, they start in your most familiar grid right here, which is positive numbers, and they go counterclockwise. You can remember where to start, and then it goes backwards of a clock. You'll be okay. You'll be able to remember 1, 2, 3, 4. Okay? All right. So one other thing to remember. This is the x-axis, as denoted right here by this x, which won't always be there for you. Okay? And this is the y-axis. All right. I think if you know those things, we'll get through today pretty well. Well, I might as well finish this up instead of doing it when we get to this page, okay? Remember that we always do y and then x when we're graphing coordinate pairs, okay? So look at this one right here. 2 and then 5. We can count on it that a positive number is quadrant 1, okay? Look at this one. It's negative, then positive, negative, then positive. So we go in the negative direction and then the positive. We end up in quadrant 2. So quadrant 2 is always negative, positive. Negative, negative will land us in quadrant 3. Negative, negative, quadrant 3. And positive, negative will land us in quadrant 4. Positive, negative. Okay? So you can look back at this chart if you're unfamiliar with that and learn it, okay? Or as you graph coordinate pairs, it will become more obvious to you. All right, let's go back to page 1. So here's our real world link. The map shows the layout of a small town. The locations of the buildings are described in respect to the town hall. Each unit on the grid represents one block. Okay, so describe the location of the barber shop in relation to town hall. So let's find those things. So here's town hall, and where is that? Oh, and here is the barber shop. So we could say that the barber shop is 1, 2, 3, 4, 5 units to the right of town hall. 5 units to the right of town hall. If we wanted to get really fancy, we could say north, south, east, west, and say that the barber shop is 5 units east of Town Hall. Cool. Okay. What building is located 7 blocks east and 5 blocks north of the Town Hall? So here's east and north. Here's Town Hall. 1, 2, 3, 4, 5, 6, 7. And then how many? 5 blocks north. 1, 2, 3, 4, 5. The firehouse. The firehouse is 7 blocks east and 5 blocks north. And number 3, Violetta is at the library. Describe how many blocks she should travel to get to the supermarket. So here's the library, and she wants to go to the supermarket. You may get different answers here, depending upon whether you go east and then south, or south, and then east. I'm going to go south first. So that's 1, 2, 3. Is that enough? 3? Yep. 3 blocks south. 3 blocks south. And then 1, 2, 3 blocks east. 3 blocks east. That's kind of fun. So Town Hall and Bank are both located on the same vertical number line. The number 0 represents, oh, by the way, in coordinate grids we call the 0 the origin. I don't know if they're going to mention that in this lesson, but it is a good thing to know. What number represents the location of the bank? 0 represents the location of Town Hall on the number line. What number represents the location of the bank? So here's Town Hall. Where is the bank? So that would be 1, 2, 3, 4. And they're only asking for the number for the y-axis. Okay, so technically it would be 0 because we don't move on the x-axis at all, comma 4. Okay, but I believe they're only asking for the y-axis. All right, let's move on. We already reviewed the quadrants of a grid, so we're going to move to number 1. Identify the order pair that names point C. So here's point C. X first, right? So, look, let's make this big here. Look at this. It's important to notice how it's labeled, 1/2, 1, 1.5, okay? So we're going to have a different pair. So we have 1/2, 1, 1.5 for the x-axis. So that'd be 1.5, comma. And then how far up? 1/2, 1, 1. Okay, simple enough. Number 2, identify the point located at -1.5, -1. So we already know that's going to be quadrant 3. Let's try it. X-axis first, -1.5. That's right here. And then down 1. Down 1. Right here. So that is B. Okay, B in quadrant 3. Let's move on. It says, refer to example 1, identify the order pair that names point A. Then identify the quadrant in which it's located. So point A, that would be -1. And then we go up, what is that? 1.5, comma, 1.5. And that is quadrant 1, 2. 1, 1.5. So -1, comma, 1.5. Quadrant 2. Okay? Refer to example 1. Identify the point at 1, -2. Then identify the quadrant. So positive, then negative. That's going to be quadrant 4. Let's go take a look. 1, -2. So, which example? Sorry. That was example 1. Okay. 1, 1.5, 1.5, 2. Point E. So point E, and that's in quadrant 4. All right. You can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and coordinate plane below. The number line shows that -4 and 4 are opposites. The coordinate plane shows that the points -4, 0 and 4, 0 are the same direction from the y-axis in opposite directions. They are reflected. Oh, there's another vocab word, reflected. Like mirror, reflected, across the y-axis. Notice that the y-coordinates did not change and that the x-coordinates are opposites. All right. Name the ordered pair that is a reflection of -3, 2 across the x-axis. Okay. So when it reflected across the y-axis, what changed? The x-coordinates changed. So that means we know that in this one, if we reflect across the x-axis, then the y-coordinate should change. Okay, so x-coordinate will stay the same. Y-coordinate will be the opposite of 2, which is -2. Okay, and let's see if we're right here. Here's the original, -3, and then 2. There's the original right there. So the opposite would be -3, -2 right there. Okay? And they said to name the coordinate, I assume. Okay, let's try some. Name the ordered pair that is a reflection of each point across the x-axis. So if we're reflecting across the x-axis, we are changing the y-coordinate. Okay? All right. So this one would be 1, +4. This one would be -2, -5. And this one would be -3, 1. Simple. And if you get confused by that, you could always graph them just to make sure you did it right. No problem with that. All right, example 4. Kendall is building a square fence. She places fence posts at the locations indicated on the grid. Okay. What is the location of the post that reflects -4, 4 across the y-axis? All right. So if we are reflecting across the y-axis, we change the x-axis coordinate to its opposite. So x is -4, so that's going to be +4. Keep the y-axis the same. All right. Is that true? 4. That can't. Yes. So 4, 4. That does appear to be, except for that. 1, 2, 3. I put it on the wrong line, huh? There we go. 4, 4. Good thing I looked because it would have been wrong. Huh? All right. There's one example of good reason to check your work. Kendall also placed a fence post at -4, -4. What is the location of the fence post that reflects -4, -4 across the y-axis? So for reflecting across the y-axis, we change the x-axis coordinate. So it was -4, so we're going to make that +4 and keep the y-axis the same. Okay, let's see if we're right. Here is -4, -4. Okay, and +4, -4 would be right here. So we have our corner fence post in. I hope she put some in the middle, but it looks like she did. This is a little blurry, but maybe you can see better. Let's practice. It says identify the ordered pair that names each point or the name of each point. Then identify the quadrant it is located in. I think since we're a little new at this still, let's just go ahead and name the quadrants right now. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. That way we won't have to think about it. We just have that work done, okay? So T, let's look for T. Anyone see it? Oh, here it is. There's T right there. So that would be -1.5, -2. quadrant 3. Negative 1.5, negative 2, quadrant 3. And then the next one is negative 1.5, same spot, 0. Oh, it's right here, K. What quadrant is it in if it's on the line? That's an interesting question. What do you think? What quadrant is it in if it's on the line? None. We'll call it none. It's not in a quadrant. It's on an axis. So I guess we could say it's on the x-axis. But the zeros should tell us that. Okay, negative 2, 2.5. Negative 2, 2.5. It's positive 2.5. B. B. And what quadrant is that one, 2? Quadrant 2. Okay? Now we've got a diagram with locations, such as this cafeteria here. That's good to know. Maybe it's college. What is located at the reflection of negative 3, 4 across the y-axis? So we'll change the x-coordinate in order to figure that out. X, Y. So that's going to be positive 3, keep the y-axis, negative 4. Let's go find that. Positive 3, negative 4. That's the gem. Okay. What is located at the reflection of science labs across the x-axis? Science labs, let's find them. Here's the science labs, and it's across the x-axis, so we'll change the y. Okay. Science labs is at 1, 2, 3, negative 3, negative 2, negative 3, comma, negative 2. So if we change the y-axis, that becomes negative 3, comma, positive 2. And what is there? Negative 3. The art studio. Art. Okay. How are number lines and coordinate plane related? Well, the axes are like the number lines, right? So we could say, do you guys know what an intersection is? Like where two streets meet and there's stop signs or a signal. So we could say that a coordinate plane is the intersection of the x number line and the y number line. Coordinate planes are the intersection of the x and y number lines. It's an interesting thought. How are you feeling about this one? Remember, you can ask for help if you need it. You can also work with a friend. Have fun. Whisper quiet. Thanks, guys. Bye-bye.